Hey guys, it's Andre from High Performance Academy. Welcome along to this week's webinar. This week we're going to be diving into a quick introduction to the ECU Master EMU Black. So it's an ECU that we've actually been trying to get up and running for a fair while now. Finally found the time to finish off the installation on our V11 Subaru STi. Got it all up and running, got a few bugs ironed out that generally always pop up when you are installing any new ECU. And we're about 3/4 of the way through filming a worked example that's going to be added into our practical reflash tuning course, which covers exactly how to use the ECU Master EMU Black. So today's webinar is designed to just be a bit of an introduction, a bit of a tour through the software so you can get a bit of a feel for the ECU, what it does, how it functions, and I'll give you a few of the simple shortcuts that I've picked up over the time I've been using the ECU so far. And I'll profess right now, I certainly can't claim to be an expert on the ECU Master, but it's definitely something that I've enjoyed learning, so we'll see what information I can pass on. Before we get into that though, just an update on everything that has been going on over the last week or so. And last week I talked about the fact that we were doing an upgrade on the brakes on the rear of our black Toyota 86 race car. And if we jump across to my laptop screen, Brandon got busy on Fusion 360 again and designed up this little bracket here, which is designed to adapt up the new endless 4-pot calipers and the endless rotor. So that was the only part missing from that full endless kit. And for some weird reason, the bracket that we needed actually ended up being crazy expensive. So it made a lot more sense for us to just make one up ourselves. Now this really needs to be thought out quite carefully. Understandably, it's a mission critical part of the brake system, so we want it designed strong. We definitely don't want any chance of a failure on that bracket. At the same time as well, we do need to make sure that the bracket is designed to correctly locate the caliper so that the pad is sitting on top of the brake rotor and that it is centralized over the brake rotor as well. Otherwise you're going to have problems with maybe a pad binding or maybe not getting full engagement between the pad surface and the rotor. So again, we got our 3D printer to action, and this is prototype number 1 of that brake caliper adapter. And really, although we only have had this 3D printer for a short period of time, it really has proved invaluable to the point where now I kind of wonder how we ever managed to get on without one. And for those who are wondering, we've had a few questions on Instagram as well as our YouTube channel. The unit that we've got is nothing particularly special. It's a Creality 3D. Foolishly, now I can't remember the exact part number. Not too helpful, but the unit we've got works out to be, I think, around about $700 US. So and it's not crazy expensive. It's something that is within the scope of a home enthusiast who's going to get a little bit of use out of this. These things have come down massively in value over the last sort of few years, and particularly when you've got the power of Fusion 360, which for private use at least is essentially a free piece of software. Incredibly powerful as long as you can get your head around learning the system, of course. So again, back to my laptop screen, we've got the brake caliper all dummied up there on the rotor. Everything looks like it's clearing. We've got good clearance to the wheel itself. That's actually a bit of a problem for us as well, because we are running a 17-inch wheel here, so clearance between the outside of the caliper and the inside of the wheel was something we needed to be mindful of, but no big issue there. It's all working. And here we can see the 3D printed bracket that is sitting there while we dummy everything up and make sure it's all going to work. And the hubs here as well, if you are wondering, this gold hub here is actually a Parts Shop Max hub. So we had these on the car when we purchased it. Does some roll center correction, basically some geometry correction, which works out for lowered cars. So now that we've got all of that tested out, we know that everything's working. We can get a component actually machined in alloy. Obviously a little bit stronger than plastic, a little bit more reliable, but we can have the confidence that when we get that part back, it is going to bolt straight on and everything's going to work. Now we still are in the midst of waiting for some of our engine components for the 3U ZFE, the 4.5 litre variant that we are building for the engine and for the car, and at the moment we're waiting on JE to produce us some custom pistons for that engine, given the bore diameter, the compression height and the compression ratio that we're after there. It needs to be pretty specific to get us onto our target. We're probably still expecting those to be a few weeks away. The heads were in the CNC porting machine this week, so those should be ready to go, but the block of course needs to wait for these pistons so we can make sure that it's been machined with the correct piston to cylinder wall clearance. So pretty excited to get that all back together, but in the meantime there are a few other tasks that we were able to tick off, given that the engine had what was a pretty catastrophic failure. Not a lot left of it. It failed at about 8,500 RPM, and for those who did manage to see some of our pre-shows back when we were pulling it to pieces, we had so much debris strewn all through the engine. The airbox actually ended up with the better part of half a piston in pieces up inside of it, as well as some rings. So yeah, when an engine lets go at 8,500 RPM, not a lot of good things happen. One of the problems with this as well is that the engine was dry-sumped, or is dry-sumped, and of course some of those components from an engine failure can end up going through the dry-sump pump. Generally you would include a scavenge filter. This didn't really have a very good scavenge filter built into the sump, so we're a little bit mindful of pulling that apart to see what we found. We'll jump across to the laptop screen again, and this is the Peterson dry sump pump in component form there. It is a 3-stage pump, so it's got 2 scavenge stages, which are these components out here. These extract both the oil and blow-by gases out of the crankcase, and then the third part here is the pressure stage, which pumps the oil back through the engine. Oops. Nope, definitely don't want to do that. What you should be able to see reasonably easily there is the pressure stage. The gears themselves are actually in pretty good condition, and we weren't too surprised by this. The pressure stage, the oil has already come from the reservoir, it's filtered, so should be relatively clean at this point. However, the scavenge stage is not quite the case, so we can see that the housing there for one of the scavenge stages was showing a little bit of marking there from debris going through it. Nothing particularly catastrophic there. Whoops, not that one. I don't think I've got a photo of the gear. The gears themselves were, however, looking pretty shabby, so we're just waiting on some component prices from Peterson there, and we'll probably replace at least the gears from one of those scavenge stages. Now, it's not super critical, they weren't bad, but the problem with it is that in order to do the best job possible of scavenging the oil and blow-by gases out of the sump, we do really need the scavenge gears to be mating really, really tightly, and particularly when we only have 2 scavenge stages. Normally you'd probably fit a 5-stage pump to an engine like that, where we've got 4 scavenge stages. In this case we've only got 2, so we really want the 2 stages that we've got to be doing the best job possible. The idea behind this is that ultimately we'd like to be able to pull a vacuum in the sump, and there are some performance advantages around that side of things as well. So we'll see what we can do. We never had the advantage of a crankcase pressure sensor when we were running the engine last time. With the new engine going together, we will be adding a crankcase pressure sensor, so we'll be able to log all of that. And that's also a good way to keep an eye historically on the data and keep an eye on the health of the engine. As the ring seal starts to go away, you'll start to see your crankcase pressure drop away, or you'll be pulling less crankcase pressure than when the engine is fresh. So it's a good way of just keeping an eye on things. If you've got that data race after race after race, you can sort of start comparing the values that you're seeing. Now, the other thing we decided to redesign here was the shifter arrangement. Now, I'm not too sure how easy it's going to be to see here on our GoPro in car, but this is the shifter that we were using with our TTi gearbox. And the TTi gearbox is a little unique in that it runs dual levers, so it's got one for the forward gears and it's got a second reverser. My understanding, talking to Bruce from TTi, is the design essentially reduces the cost of manufacturing the gearbox, but it does get a little bit awkward from an installation perspective. So this original lever that we went with was designed to basically eliminate the dual levers, and it's got this little lockout on the front of it here, and basically depending whether you want to be going into the forward gears or the reverse, you'd slide that lever across and it would essentially select either the forward or the reverse gear. Good in theory, problematic in use. First of all, it wasn't particularly rigid, didn't really give a lot of positive feel to the driver, and we also ended up figuring out that it was possible from the reverse lever to actually still select a forward gear, or try and select a forward gear, which isn't exactly ideal. So we've reverted back to a dual lever system, and as part of that, Brandon went through a bit of a redesign of the lever itself. So I'll jump across to my laptop screen. So this is the new design that we're just in the process of prototyping up now, again designed on Fusion 360. So we've got a Motorsport Systems strain gauge gear knob. He's managed to do a fairly nice job of integrating that with what's going to end up being a alloy shifter. The other thing with this as well is the ability to then slot the back for the wiring that comes from the Motorsport Systems strain gauge. Down the bottom here there is an integrated spherical bearing as well, so this is pressed into the shifter itself. Obviously we can't run the alloy directly on the through shaft, that's going to end up wearing, so the circle bearing that goes in there is then retained with the circlip as well, and then at the bottom we've got a threaded section here which will connect to the output. So this is the current prototype that Brandon's printed out. Actually had a bit of a problem when we printed this one out, as the 3D printer had been moved, so it's not ideal. And this is another example of what you can do with the 3D printers. This component is actually too large to print in one piece, but you can design it to just dovetail together, so perfect for our purposes of prototyping. And then again on the back, it's a little bit ugly at the moment, but the there's a little recess, as I mentioned, through there for the wiring to go through for that lever. So once we've confirmed that that all fits, that'll get printed up. We'll get that made out of alloy, and we should be one step closer. We've still got a few months before the first round of the Endurance Championship, but things tend to get away on us, and we've still got a lot of work to do. So in particular, there's some aero work to do. There's a diffuser at the rear that's being built over in Australia by Top Stage at the moment, as well as a front splitter and another rear wing as well, which is going to be a little bit more professional and a little bit more efficient and effective, hopefully, than our Kmart special that we were running on the car last season. So look forward to getting that a little bit further along. Now I just also wanted to jump across and just cover off briefly one of the Instagrams I put up last week. So this was a shot that we took at World Time Attack 2019. Sadly, with COVID etc, World Time Attack isn't going to be running this year. It's a real shame, because that's an event we've been going to for I think about the last 5 years. It's always a great event to see what the teams are doing to push the boundaries. Nothing particularly new about this photo here from the Tilton Evo in terms of the turbo technology. It's running a BorgWarner EFR 9180, but it is the split pulse exhaust manifold that I was just talking about in this particular Instagram. And I think most people understand the purpose of the split pulse manifold is to basically time the pulses from the different cylinders to gain an advantage in terms of turbo spool up. So a little bit of routing problem. It does add a little bit to the complexity of the way the exhaust manifold is designed and built. However, one aspect that is quite often overlooked is the way the wastegates are integrated. So conventionally, even with a T4 exhaust manifold like this, we could run a single wastegate, and we could certainly control boost with a single wastegate that's sized correctly. However, in order for that split pulse or twin scroll style exhaust housing to work properly, we really want to make sure that the individual scrolls are separated right up to the point where the exhaust gases meet the turbine wheel. And if we had a single wastegate, that would generally be sort of spread across both scrolls there, and it makes it a little bit tricky. Yes, you can add a divider that runs right up to the wastegate valve, but that in itself is problematic and adds to the complexity of the fabrication process, which is why you can see it's quite common to see with these split pulse style exhaust manifolds where twin wastegates are incorporated there. Allows also smaller wastegates to be used. Obviously they're only venting half of the exhaust gas flow. It's still important, and you can see there's a little bit of detail in here with the collector itself, where they've tried to integrate the wastegate so that the flow is biased towards the wastegate. If you've got the wastegate coming off at 90 degrees or at a really acute angle to the exhaust manifold, it makes it difficult for the exhaust gas to easily flow out of the exhaust manifold into the wastegate, and you can see a situation with this where you'll end up with boost creep at higher RPM. Now also the video that we've just released today, we'll just head across to our YouTube channel, and I generally recommend after you've watched this webinar, head across and have a look at this video if you are interested in electric vehicles. This was a video we shot back last year at PRI with Sasha from OnPoint Dyno in Canada, and Sasha pretty much embraced the whole EV revolution fairly early on, to the point where he actually built a Lotus Evora and swapped in a Tesla electric motor. He got that all running on a custom MoTeC package that he wrote himself, so pretty cool. He's gone into this even further these days, starting up his own business, developing in particular suspension components for tuning the Tesla range of vehicles. But in this video we talk a little bit about what's involved with electric motor technology, electric vehicle technology, and how that's going to be controlled, in particular the way the inverter works to control the electric motor, and how we can integrate external electronics such as the MoTeC ECU to control that. And this is one of the advantages with a system like the MoTeC, where basically it is just a blank box of electronics, and you can essentially write your own code using MoTeC build to make that ECU do just about anything that you want it to do. Now Sasha's done this himself, and we talk about what's involved with that. However, there's going to be, as we see more development in this industry, there's going to be more off-the-shelf packages and options available for those wanting to do their own EV builds or engine swaps, electric motor swaps. To the point, actually, at the same show, AEM were also displaying their what was then newly released EV range of ECUs. So we're going to see more and more of this. Now, part of what we talked about in this particular video was Sasha's own time attack car, which is a Nissan 350Z, and he's got arguably one of the most powerful VQ engines naturally aspirated anywhere in the world. I think it's running somewhere in the region of about 450 horsepower at the wheels. Don't quote me on that, but you can dig in a bit deeper if you want to find out more. That wasn't enough for him though, so with his love of electric vehicles and technology, he actually pulled this apart and basically made it into a hybrid. So he's replaced the flywheel and clutch unit with an electric motor that sits in the bell housing. So that actually is what couples the engine to the sequential gearbox behind it. It's turned into a paddle shift system, and we learn a little bit more about how that adds 200 horsepower to the total output from that VQ35 and 37 I think it was based on, getting up to around 750 horsepower. Now at the time we shot this, the 350 wasn't actually up and running. It was waiting on a couple of final components, but of course that's now been up and running. And if you do want to learn a little bit more about that as well, we'll head across to Speed Academy's YouTube channel. Our friends from Speed Academy work really closely with Sasha, and they headed along to Toronto Motorsport Park to film the first outing of that car on track. So check that out. It certainly looks like a handful. In my opinion, probably one of the wildest sounding 350Zs. So check that out if you are interested. Speed Academy do a great job. Alright, last but certainly not least, we are running another one of our giveaways, this time for this HPA IC7 dash display unit. So these have been out for a little while now. We've been lucky enough to have our hands on one for a while. They are a dash display, not a logger. That's important to mention, but particularly if you are looking at adding instrumentation to your project car, this can be a really cost-effective option. Gives you a lot of configurability in the way you can display data. The nice thing with the HPA is that it isn't just restricted to working with HPA components. It talks to the ECU, excuse me, I'll try and get my words out, via CAN. So all you need to supply this with is power, ground, and CAN high and low, and you can get the data from basically any popular aftermarket ECU that provides a CAN data stream. Of course, if you are dealing with a MoTeC ECU, this is as simple as plug and play into the CAN expansion port on the Elite series of ECUs, making it really easy. Range of different displays configured, or you can configure your own. Nice feature with this dash is you've got these big tactile buttons on the side of it to control the displays. So it does everything you'd expect from a digital dash. You can display all of the data in a range of different ways. You can set up alarms as well, so if anything goes outside the realms of what you're comfortable with, you can automatically safeguard, or at least alert the driver to the problem to safeguard any damage to your engine. So this has only just recently gone live, our giveaway. I'll get the team to drop a link in the comments that you can follow if you want to get your name into the draw for that IC7. At the same time, you're also going to, the winner will be receiving our tuning course package suite of courses, as well as a package deal. There are also a couple of other little tasks you can complete to get further entries into that draw. Absolutely free to get into the draw. We'll ship it anywhere in the world, so get on top of that quickly. Alright, give us a moment and we'll get started with today's lesson.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.